All right, here we are again. This time we're going to talk about a geometric series, which is kind of based on the same pattern as a sequence, which we have in front of us. But the series is actually going to add the terms up. So we'll jump right in. What we have here is a geometric sequence. Last video we talked about how this is called our first term, our second term, our third term, our fourth term. And then subsequent terms, fifth term, sixth term, we'd have to find by finding the pattern. Quickly as a review, we can find what's called the common ratio by looking at two consecutive terms and taking the ratio of consecutive terms. Again, when I divide by a fraction, I can also multiply by the reciprocal. And in this particular example, my 2's can be simplified, and it looks like my ratio is -3. So that is the quote-unquote pattern that's being multiplied. If you take this and multiply it by 3, you get this term. If you take this term and multiply it by 3, you get this term, etc. If you wanted a formula, again, review of a sequence, if you wanted a formula for that, you could say it's the first term times your r to the n minus 1. And that would be a formula to find any term you wanted. But we are now talking about what's called a series. And a series is when you start adding up these different terms. We use a big S to represent the sum. And if you see something like S2, what that means is I want the sum of the first two terms. In this case, the sum of the first two terms would be 1/2 plus -3/2. And if you add that up, it looks like you get -2/2, or you get -1. If you wanted S3, you would add 1/2 plus -3/2 plus 9/2. And again, I already have a common denominator. So I have 1 minus 3 plus 9. And so 7/2 would equal the third partial sum. They're called partial sums because you're taking sums of a partial sequence. Again, S4, I would add up these four terms written up here, but I think you guys get the idea. S1, not very exciting. S1 is just 1/2. We're not adding it to anything. One thing I would like to point out, just really quickly, is that there is a formula to find the sum of n number of terms. And that formula is A1 times 1 minus r to the n over 1 minus r. Let me use this formula on a different example real quick. I'm going to pick a slightly easier one, just because I don't happen to have a calculator with me. And I don't want to start taking high exponents of fractions. But let's look at a quick example that we just have, 1, 2, 4, 8, 16, and so on. Looking at this, the r is 2. You can think of it as 2/1. And let's just quickly find S5 using my formula. S5 is equal to the first term, which in this case is 1, times 1 minus r to the nth power. Again, the n is right here, over 1 minus r. r is 2. So according to this, it says that S5 is 1 times 1 minus 32, right? Because 2 to the 5th is 32, over 1 minus 2 is negative 1. So s to the 5th is 1 times negative 31 over negative 1, which it looks is going to be 1 times 31. So we can say the 5th partial sum is 31. And just a quick little check here to verify it. Doing it the old-fashioned way, s to the 5th is the sum of these first 5 terms, 1 plus 2 plus 4 plus 8 plus 16. So we got 3 plus 4, so we got 7 plus 8 plus 16. So we got 15 plus 16, which is equal to 31. You might be asking, why didn't I just do this? It's a lot shorter, the notation's a lot tamer, but the power of this formula is if I asked you for, S100. That's saying I want to know the sum of the first 100 terms. And that would take a long time, and not to mention the number would get very large pretty quickly. But it could be found by evaluating this expression, saying, okay, 2 to the 100th power over, 1 minus 2. And when you simplify this, you would get an exact answer for s to the 100th. This formula and this type of problem, these sequences and series, come back and play a relatively large part in calculus. So, all right, thanks for watching.